Example number 9, we're simplifying exponential expressions. We're going to simplify each expression and then write the answers with positive exponents only. So in the first part, we have a base which is inside the parentheses of 6m squared n to the negative 1 power raised to the third power. Now if you notice, the base of 6 has an exponent of 1. So we have 6 to the 1 raised to the third power, m squared raised to the third power, and n to the negative 1 raised to the third power. So we're using the power of the product rule. Next, we have 1 times 3, which becomes 6 to the third power, m to the 2 times 3 times n to the negative 1 times 3. So 6 to the third power, if we take our calculator out, we know that 6 raised to the third power gives us 216. 2 times 3 is m to the 6th and n to the negative 3. Now 216 has a positive exponent, the base of m has a positive exponent, but n has a negative exponent. So we're going to use the negative exponent rule, so we're going to make that a positive exponent by making n to the third power in the denominator. So our answer is going to be 216 m to the 6th divided by n to the third power. In part B, we have 17 to the 5th power times 17 to the negative 4th power times 17 to the negative 3 power. They all have the same base, and when we're multiplying them, that means we add our exponents. So we have 17 to the 5 minus 4 minus 3. So we get 5 minus 4, which is 1, minus 3 gives us negative 2. So we have 17 to the negative 2 power, which becomes 1 over 17 squared. Now, we don't want to leave that negative exponent, which is the reason why we're writing that in the denominator. But 17 squared is equal to 289, so the answer is going to be 1 over 289. In part C, inside the parentheses is the base. We have u to the negative 1v over v to the negative 1 squared. So in the numerator, we have u to the negative 1v to the second power. In the denominator, we have v to the negative 1 to the second power. And then we're going to distribute that 2 to the exponents. So we end up with u to the negative 2 times v to the squared, positive 2, divided by v to the negative 2. So we have u to the negative 2, and here we have v, which is the same base. So that means we have to subtract our exponents. Now pay attention here, because we have 2 minus a negative 2, which actually becomes 2 plus 2, which is 4. So we have u to the negative 2 times v to the 4th power. And again, we don't want to leave negative exponents, so v to the 4th power stays in the numerator. In our denominator, we have u to the positive 2. In part D, we have negative 2 a to the 3rd power times b to the negative 1 power times 5 times a to the negative 2b to the 2nd power. So if we multiply this out, the first thing we want to do is use the commutative property of multiplication. So we have the constants, which is negative 2 times 5. And then we have a to the 3rd power times a to the negative 2nd power. And then we have b to the negative 1 times b to the 2nd. Now again, this is all multiplication, which allows us to be able to write it out that way. So we have negative 2 times 5, which is negative 10, times multiplying the same base, we're going to add our exponents, so we have 3 minus 2. And again, multiplying the same base, we have b to the power of negative 1 plus 2. So we end up with negative 10. 3 minus 2 is 1, so we have an exponent of 1, which is just a. And then negative 1 plus 2 is also 1, so we have b. So the answer is negative 10ab. In part E, we have a base of x squared times the square root of 2 with a power of 4. And then we have multiplied by the base of x squared, square root of 2, to the power of negative 4. Now again, since it's the same base, we're going to multiply that by adding the exponents. So we have x squared times the square root of 2, and we're going to add our exponents, which is 4 minus 4, which becomes an exponent of 0. Now regardless of what the base is inside the parentheses, it has a power of 0. By using the 0 exponent rule, the answer is 1. In part F, we have a numerator of the base of 3w squared to the power of 5 divided by the base of 6w negative 2 to the power of 2. So we're going to use the power of the product rule by multiplying the exponents, the power of the exponents to the power of what's inside the base. So the exponent for 3 is 1. So 5 times 1 is 1, so this is 3 to the 5th power. Then we have w squared to the 5th power. Now again, 6 has an exponent of 1, and w has an exponent of -2. So we have 2 times 1, which is 6 to the 2nd power, and this becomes w to -2 to the power of 2. So we end up having 3 to the 5th power times w to the power of 2 times 5. In the denominator we have 6 squared times w to the power of -2 times 2. Now 3 to the 5th power is 243 times w to the power of 2 times 5, which is 10. And the denominator 6 squared is 36. And that's w to the power of -2 times 2, which is -4. So if we simplify this 243 divided by 46, that means they both have 9 in common. So 9 goes into 243 27 times, and 9 goes into 36 4 times. And then we can see here that we have a base that we're dividing, the same base. So we have w to the power of 10 minus the exponent in the denominator, which is -4. So since it's 10 minus a -4, it becomes 10 plus 4. So we have 27w to the 14th power divided by 4.